Dzień dobry, Serverless Day Warszawa. My name is Gojko, and I'm going to be talking about shaving milliseconds from serverless function execution to get really super responsive apps. Within the context of serverless deployments, usually platforms are optimized for very high throughput and very high parallelism, but not necessarily for low latency and responding to each individual request so that it's very quick. In fact, there's a lot of variance around starting new instances, allocating more capacity, and different requests can get very different response times. That's why there's a lot of misunderstanding online about getting high performance from Lambda functions and Google Cloud functions, Azure functions. And I'm going to give you 5 rules to think about to make your serverless apps as fast as dedicated hardware in terms of at least users, what they can observe. So most of the advice I'll give you applies to pretty much all serverless deployments. Some advice is very specific to Amazon's architecture and Lambda functions because that's what I use. And a lot of this stuff really changes very frequently. For example, just a few weeks ago, Amazon announced the ability to just flip a switch and run functions on Graviton 2 chips. Their ARM-based design that's much faster, much better, much easier and cheaper to use. And in their official announcement, they talk about how, in average, you can get up to 19% better performance, plus they're selling it 20% cheaper. So this sounds almost too good to be true. You flip a switch, you speed up your Lambda functions, and you pay less. And this is amazing. I built a couple of apps that run on Lambda. One of them is a platform to help developers to turn markdown files into narrated videos easily and create short explainer videos. And this is backed by Lambda functions. It's backed by Fargate and things like that. And being able to flip a switch and offer 20% better performance at 20% lower cost sounds amazing. But I didn't just jump into this. I actually spent a few hours testing it. And my conclusion is that for the workflows that the app runs, actually, Intel performs still a lot better. And you can find the detailed report of this on erakit.com tech Graviton Lambda FFmpeg HTML. And you can see the test I used and the conclusions from this. But generally, for me, it turns out that the old platform, despite all the marketing of the ARM-based hardware, is still better. Maybe the ARM hardware will improve in the future, but don't jump onto this yet. So should you avoid this based on my results? Probably not. My workflows might not be the same as yours. FFmpeg might be not optimized for ARM, and your workflows might actually work much better. Or they might not, although my test might not be relevant for the classical web app scenario. The people at Honeycomb ran a similar test on their functions in production, doing canary deployments, and they concluded that their functions also ran 20% slower on ARM with a much higher variance. So what happened here, nobody knows really. It's a new platform, it's emerging, and people are not getting the results they expected. Again, this might be completely different for you. So the number one rule in really optimizing serverless functions for very high performance is do not trust anything you read online, especially if it's more than a few months old, because best practices from last year might no longer be good practices today. Plus, your workflows might be different from other people's workflows. So really trust everything you read, enough to test it, but think about your workflows and whether these things apply to your situation. Unless you try it, you really can't know. One thing that I really encourage people to test, where there's a lot of misunderstanding, is how to deploy APIs. For example, there are 2 ways of deploying APIs backed by Lambda functions. One is to deploy it in a region, and have clients connect directly to that region. And the other is to deploy what Amazon calls edge optimized endpoints, which means that your API will be deployed in one region, but the routing will go through Amazon's CloudFront points of presence, which they say typically improves connection time for geographically diverse clients. So if I'm accessing an edge API from Europe and the API is deployed in the US, my request will go to the closest Amazon's point, maybe Frankfurt or London, and then through the Amazon pipe goes to the US. And this should really optimize connection time. It sounds logical, it's intuitive, and there's lots of these connection points everywhere around the world, but does it actually work or not? Well, that's easy to test. So if you deploy an API, you can basically say endpoint configuration regional or endpoint configuration edge, deploy both things, bombard it, and look at your workflows, and you will conclude whether it's better or not for you. For example, for the workflows I use, actually from Europe to US, it turns out that edge is not actually faster than regional. Having an API deployed in the US from North Europe, connecting directly to it instead of going through the Amazon pipe, the regional seems faster. Why? I don't know. Probably the North Europe and East US are well connected anyway. If we ran this test from Australia, the results might be completely different. And it's important, again, to understand where most of your users are, where this thing is going to be deployed, and test yourself. If you want to run tests like this, by the way, I've open sourced a tool called Inquisitor that allows you to very easily deploy lots of different combinations of functions to different regions and test them very easily to get these numbers out. So another thing that's really interesting about optimizing performance for Lambdas is how most advice online talks about avoiding cold starts and preparing stuff to wait for clients while nobody's using them. And this is really bizarre because if you look at the original idea of Lambda and what people were talking about when the platform was emerging is basically that one of the biggest benefits of Lambda and serverless functions in general is never to pay for stuff waiting. And this is kind of directly from Tim Wagner, who was the manager responsible for Lambda at reInvent 2016. He says that the serverless model is deliver whenever you want to deliver and never really pay for waiting. And then if you look at kind of the advice online, all of it is basically, well, keep Lambdas warm. Keep them running, pay for nobody really talking to it. There's people talking about how to shave latency, what they do is when a user comes to the page, they send a request to a Lambda function before the user sends another request so that the instance is already there. And this is really, really strange because it goes against the idea of the platform. But hey, you know, people wanted to pay for that. So we got Enterprise Lambda sometime in 2019. Azure first started these kind of enterprise functions where on a premium plan you could have them pre-warmed. And then Amazon realized people are paying for this, so you know, why not take their money? So a bit later in 2019, Amazon allowed you to just say, well, provisioned concurrent executions 20. This means you're going to have 20 Lambda instances running all the time, even if nobody's using them. Now, in theory, again, that gives you much, much better performance because you have some instances already running, the call starts are not happening, but test it. Your workflows might be different. For example, again, running workflows on Node.js from London, going to the EU West 2 region. I ran this test in February using Inquisitor. My conclusion was that basically without provisioning I get slightly better performance. There was more variance but slightly better performance. What's even more bizarre is I wanted to run a test that would be the equivalent of what the provisioned instance is allocated. So I first ran a test without provisioning, got 12 different instances responding to this stuff and thought, okay, I'm going to provision 12 and run it. And as a result, I actually had 26 different instances running on this, because provisioned doesn't necessarily mean maximum. It just means keep running this stuff. And that's why I guess provisioning is not necessarily always going to give you the best results. Now, of course, you can pay Amazon for crazy things like auto-scaling policies where they're going to start guessing how much of provisioned functions to serve. And you can very easily say, I want 70% of the stuff to be served by provisioned functions, and they're going to auto-scale this and guess the right number. But this stuff is just amber. Provisioned instances are amber, and amber means actually they're just making Jeff Bezos even richer. So in most cases, we can avoid this stuff by designing our functions to avoid being blocked when they start. And this whole craziness about cold starts was a problem in 2016. It's not necessarily no longer a problem, especially for web requests where the users are used to flaky Wi-Fi's, they're used to a couple of 100 milliseconds of responses. Mikhail Shilkov publishes this amazingly good research every few months. The last data he has at the moment is from January 2021. You can find it on Mikhail.io. And his conclusion is that if you really want to look at AWS, he publishes for other platforms as well, and you're running inside Node.js or Python or Go, cold starts are at the order of magnitude of like 25 to 50 milliseconds. And this is not necessarily something that you need to care about anymore with web requests. So rule number 2 is really stop caring about Lambda cold starts and focus on your function time to start. Because in a new instance, if there is a cold start, and you optimize your code to start speedily, most users will not notice anything after a cold start when a new instance gets created, and the rest becomes very simple. Then you don't have to care about complicating your architecture. So focus on getting your functions to start quickly. Now, for other platforms, things might be different here. For example, Mikhail also publishes data for Azure, where you can see that kind of there's a couple of seconds and up to kind of, 25 seconds start time. So in this case, you really might want to keep some functions warm to reduce latency. Now, what does this mean practically? Well, if you have a Java function, there's a part that executes statically once per cold start, and there's a part that executes on every request. So move all the kind of very, very slow stuff basically to be on, avoid the cold start stuff, and potentially think about caching these things to optimize them and really make starting of the function quick. If you look at Node.js stuff, again, Python and similar things, stuff that's outside of your handler is done once per cold start. Stuff inside the function is done on every request. And the common sense logic says do the stuff that happens once only above, but don't. Optimize the functions for starting quickly, and then you can deal with caching later. And this brings us to rule number 3, which is really cache the context. There's a lot of advice online talking about how serverless is stateless and how you should avoid thinking about state, but that's not necessarily true. All serverless platforms can reuse instances. If they have hot instances, they're not serving requests. So cache the context. If there is stuff that needs to happen as initialization, do it inside the request and then leave it there. And sometimes this gets a bit counterintuitive because the context might exist even outside of your code. For example, with AWS SDK for Node version 1, the connection from individual AWS services, for example, if you're connecting from your code to S3, every request was reconnecting and doing an HTTPS handshake. For some very quick services like Dynamo, this actually took longer than the request establishing this connection. And there was an environment variable that you could set that magically reuses HTTPS connections in subsequent calls. Turning this on, for example, for our functions created a massive, massive effect. This is an actual report we had doing an A/B test, and you can see that without connection reuse, there was a lot of variance, and functions were executing roughly at half a second to 800 milliseconds. Just turning this thing on dropped functions to execute almost twice as fast without that much variance. And these were talking to Dynamo. So cache the context, figure out this thing. Luckily, with the AWS SDK version 2, this thing is turned on by default, but then again, investigate these things a bit. Thinking about stuff that doesn't really just depend on our code, one of the things that's interesting to think about is networks, because with latency and clients connecting all over the world, networks are something we cannot control. So here's a fun bit of data coming from the Cisco press. A fiber network stretching halfway around the world introduces a one-way delay of about 70 milliseconds. So if you are in Asia and you're sending requests to the US, or your kind of users are there and the service is kind of halfway around the world, there's about 70 milliseconds just light speed stuff. And the interesting thing is to consider, well, how does this affect our deployments? And if you look at, for example, deploying from requests from Europe to the US, I ran a couple of tests, and with the regional API that turns out to be kind of even faster than the edge one, I ran a test from North Europe, deploying the same API to North Europe, to East Coast US, and to West Coast US. And you can see the results here. Talking from the country where we've deployed to the same AWS region, the requests end up mostly around 30 to 40 milliseconds. As soon as we cross the ocean, we've added 100 milliseconds. Go to kind of the other coast of the US, and we've added another 100 milliseconds to this thing that totally doesn't depend on our code whatsoever. So rule number 4, if you really want to shave milliseconds, is to bring your code close to your customers. After optimizing for startup time, the biggest gain you can get in shaving milliseconds is to place workloads close to your users. Now, luckily, there's a couple of things that all of these platforms allow us to do. If you're on AWS, you can deploy Dynamo multi-master application so that the data goes directly to individual regions within milliseconds. You can put S3 replication that replicates 99% in a few minutes, depending on how quickly your data changes. And then you can deploy the API and Lambda functions running in different regions. The nice thing about Lambda is that you pay for utilization. So in theory, deploying to multiple regions costs you the same as deploying to one, as long as you don't do provisioned instances. And again, optimizing for start means you don't have to do provisioned instances. So lastly, I want to talk about a very stupid thing lots of people seem to do, and that is to use serverless functions like a web server. So don't know how many times I've seen people offering advice, oh, you just need to repackage the web app, run it in Lambda, put an API gateway in front of it, and basically you get this amazing scalable website. And usually the files are on S3, Lambda loads files like CSS and web files and then serves them back through the API gateway. Please, 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 please don't do this. This is totally super amber. This just makes Amazon richer at your expense. And you're just introducing moving components that don't need to be there. So one of the things to think about shaving milliseconds is to avoid the middleman where you can. For example, instead of using the Lambda functions to serve static files like JSONs and CSS and images, just kind of connect the CDN directly to S3. Also, when we're processing requests, usually people put an API gateway and a Lambda to, for example, serve a webhook and put it onto SNS. API Gateway is perfectly capable of talking to lots of different AWS services on its own. You don't need to put a Lambda in between. Just kind of configure the API Gateway to do that. Also, people sometimes put Lambda to secure access to backend resources and then load files or load data from there. Usually you don't have to do that. If you want to use security access, usually there's a way for clients to talk directly to backend resources, and maybe you can just use a Lambda to generate the security signature, so then the client can go directly to the backend if they need to. There's an even better option if you can use Cognito. Cognito allows you to authorize requests directly from clients without even generating the security signature on a Lambda function. So for example, this thing authorizes any Cognito user to access any files on a bucket prefixed by their ID. So I can access my files, you can access your files, but I cannot access your files. And if you do this, then the clients can talk directly to S3. They don't have to talk through a Lambda function. So rule number 5 is really drop delegation. Avoid using Lambda functions to transport or secure data. Use them to compute and transform data. So if you don't need to compute or transform, mostly you can avoid having a Lambda function there. And this brings me to the final interesting thing to think about. Do we even need an API gateway between a client and a Lambda function? By default, lots of people deploy a REST web gateway, back it up by a Lambda function. Services like Cognito allow you to authorize clients to use SDK calls directly against S3, Dynamo, and also against Lambda. So with Cognito, you can get an AWS SDK call on the client directly going to Lambda as a web request, avoiding a REST API. Of course, having REST APIs is good for third-party services and things like that. If it's your service, your API, do you really need that? And again, this is something that you have to test for yourselves. For example, for a typical workflow for this video production tool I've shown you, I actually did a test. And it turns out if it's deployed through an API and if it's direct, we can shave about 10 milliseconds in average. And the going directly to Lambda gives you significantly better performance, discarding all the network stuff that goes around it, so if you deploy to the same region. And that's kind of my last message. I think about whether you actually need to follow best practice advice, or if you want to shave milliseconds off, remove all the intermediaries and go directly. Thank you very much. There's a bit more about this stuff and how to use Lambdas to get high-performing websites in my book called Running Serverless. You can find it on runningserverless.com. Thank you very much.